Good morning, everybody. Welcome to this webinar series from Moxa in conjunction with our partner Hatteland Technology. My name is Simon Matthias, and along with my colleague from Hatteland, Jean-Frédéric Govin, will be your hosts. So this morning's webinar is part one of our Industrial IoT Adoption Edge Computing series. We'll take you through that. There'll be a Q&A session at the end. Please feel free to enter your questions in the chat window, and we'll deal with those towards the end. Jean-Frédéric?
Thank you, Simon, for this introduction. So hello, everybody, and thank you for joining this webinar. So as Simon said, today is the part one of the industrial product for the Internet of Things. And we will go through the introduction and so the market trend and the vertical. This is going to be presented by Herman. And then we will walk you through a storyline with example for power, rail, and oil and gas, maritime, mining, etc. And then after that, we will go through a focus on product line and what Moxa has to offer in this segments. So this will be about 30 minutes, and Igor will go through the product overview and the Industrial Linux. And then after that, we jump through an IoT application, again with Herman, and then for 5 to 10 minutes, and then 15 minutes for Q&A. So enjoy the webinar, and now I leave it to you, Herman, for the introduction.
Very good. Good morning. My name is Herman Berg. I'm the head of industrial IoT at Moxa Europe, and I hope you can see my screen. Is that true? Maybe Simon or Jean-Frédéric can say yes.
Yes, it's okay. We see everything.
So this is what Jean-Frédéric said. So let's talk for 5 minutes about IoT in select vertical markets and how we see that space and the role of Moxa. So here's a very simple slide that shows how we see sensor to cloud applications. Sensor to cloud application is kind of a synonym for IIoT. And if you can see at the bottom, that's what we call sensors for simplicity. It could be many other things than true simple sensors, could be PLCs, could be devices, machines, whatever, in the industrial field. And at the top, you have cloud applications or IT applications in general that you need to connect to. And what Moxa does is we're sitting in the middle and trying to make that connectivity happen. So we have a portfolio of industrial network equipment to connect devices that already have Ethernet ports. We have a number of edge connectivity products to connect devices that don't have Ethernet ports yet. So remote I/O, protocol converters, and serial device servers, to name the most prominent three products in that area. And then we have industrial computing, a portfolio from small ARM-based computers that we're going to hear a lot more from Igor today, to bigger Intel-based products, edge computers, and bigger specialized computers that can do the data processing and then sending the data to the cloud. So we've been in this space long before it was called IIoT, and so we do have a bit of experience. And one of the key challenges that is new in IoT, in our view, is because it became much more open than the previous SCADA environment, is how can you scale? How can the edge scale as well as the cloud can? So we still sit in the middle, as you can see on the right-hand side. And the trouble is that the edge is typically brownfield, and typically the devices that you want to connect are old and of different ages, in fact. So a lot of grown environments that take a lot of special tricks to connect the existing equipment to the network and then to the cloud. So here's our 5 critical success factors that we've come across in the last few years, or many years, in fact. In order to address the brownfield topics, you have to have a scalable IoT toolkit. Basically the things that I showed earlier on, and in particular for IoT, the IoT gateway products that we're going to hear more about from Igor. The second one today in IoT, maybe the most important one, is the ability to work with partners. We can't do everything ourselves. Typically, our customers can't do everything themselves. So often it's a really good idea to have someone who focuses on a certain aspect of the IoT solution for a living, and integrate them easily into the solution, and that's what we're definitely trying to do. Then vertical market expertise, global coverage, cybersecurity are all things that play a big role in industrial IoT and in a very special way, but we're not going to talk about that too much today. So let's have a look at two applications before we move to the actual product. Here's a power monitoring IoT application for feeder stations in Germany. It's really a fairly simple setup. We have the feeder stations on the left-hand side, gather data onto the gateway, and then send it on to a fairly standard Microsoft Azure-based cloud platform to look at the data. Why did the customer need this? Well, with renewable energies in the local grid, the distribution network, the low voltage network, additional more or less unpredictable loads have come on the network. Electrical vehicle charging stations are also directly connected to this low voltage network and present a load that wasn't there before. So really this local grid is used for things it wasn't designed for, and at the same time there is no sensoring and monitoring in that local grid that would allow us to react flexibly, or the operator to react flexibly. And that's what this is fixing. If you were using the regulated equipment from mid-voltage layers, it would be way too expensive to do that. Here, the idea is to just install it in up to 5% of the feeder station and then extrapolate from there. So you can, with only installing unregulated cheap equipment in only 5% of the stations, you can already have a really good understanding of where the network is okay and where you need to expand the network. And it's also the foundation for fairly innovative demand response like tariffs that this operator is now able to offer. Another example is gas well monitoring in Hungary. It's not very pretty yet, sorry, but it's very recent, so I thought it's good to show what's happening today. So we completed a proof of concept recently with gas wells. There's also tanks and equipment to put smell into the gas for whatever reason. So these little operations next to the gas wells need or can benefit a lot from remote monitoring and remote access. So you can check if everything's okay and make changes to some of the settings if something goes out of range. And in particular in COVID times, this would have been really useful. They weren't quite there yet, but now they will roll out because the transparency and the visibility has been really a lot increased. But let's have a look now at the gateways and what is there to know and to consider when you select the right platform for an IoT gateway of such an application. And with that, over to Igor. I think I have to now give
Thank you, Herman.
Allow keyboard and mouse access. I hope that works now. Over to you.
Let's see. Not yet. Oh, wait. 1 second. Oh, yes. Okay. Good morning, everybody. My name is Igor Božović, and I am product marketing engineer for Moxa's embedded computing ARM and x86 architecture. More than 50 years experience in Moxa with embedded computers are my best recommendations, and you can ask me whatever you want about our embedded computers. Thanks for joining this webinar, and also thanks for our hosts, Jean-Frédéric, and our colleagues, Herman and Simon, who also handle this webinar. In today's introduction, I'm going to give you a product portfolio overview of ARM-based embedded computers. As a global portfolio overview, I would like you remember that we separate our computers into two branches. The first branch is ARM CPU embedded computing platform. From these ARM-based embedded computers, which we are going to focus today, the first representative is DA Series 600A. DA stands for data acquisition. This is rack mount embedded computer, and the property is that Moxa has its own processor that we built into this embedded computer. We call it Moxa macro platform CPU to be independent of other manufacturers of CPUs on the world, like Texas Instruments or Intel. The next, what we have are embedded computers which are based on Cortex A7 CPU platform, and they are purpose for DIN-rail or wall mount computers. The representative of these computers are universal communicators, known under acronym, like you can see here, UC, Universal Communicator, 8200 series, 8400A series, or 8500 series, purposed for railway. At the end of this month, we shall have Advanced Industrial Gateway 300 series, purposed for Azure IoT connectivity. The next are embedded computers which are based on Cortex A8 CPU. They're also universal communicators, 2100 series, 3100 series, 5100 series, 8100 series, and 8100A series. They are DIN-rail and wall mount embedded computers. This first pillar we are going to cover today. In 3 weeks, we are going to introduce our x86 CPU architecture to you on 7th of April. Those computers are based on Intel CPUs, and of course are more powerful than ARM and purpose for the other parts of industry applications. Some of them are MC1100 series or V2200 series, very well and very good solid platforms. And the others are based on Intercellular Core i3, i5, or i7 or Xeon processor, purpose for power substations like DA data acquisition embedded computers, 800 series, 700 series, 600 series, then mission critical computers, MC1200 series, mission critical computers adapted for marine applications, 7400 series, or for railway applications, V2400 series C. The next, a part of this Moxa producing also panel and the computer in one, as you might know very well. And we have these computers, mission critical panel computers called 2000 series in the screen size from 7 to 24-inch screen size. They're based on Intel Atom, Celeron, or Core i7 CPU. We have also specially dedicated embedded computer for oil and gas with ATEX certification. We call it EXPC for explosive areas, 1500 series, 19-inch CPUs. A part of these computers, Moxa producing also displays between 15 and 24-inch. We call it Moxa Displays 200 series. Like mentioned, in today's webinar, we are going to focus on the first pillar of ARM CPU product portfolio. No matter, just a second, this goes very quickly. No matter how Moxa embedded computers are designed, either small, compact, palm-sized, or maybe they are box embedded computers, purpose for wall or DIN-rail mounting, or they are maybe rack-mounted 19-inch fanless embedded computers. All of the computers which are designed in Moxa are purposed to work in some industry. We focus more on Internet of Things as the latest trends in the industry, but these computers can work in the other industry like factory automation, smart factory, smart transportation, smart energy, or smart oil and gas. As a matter of fact, when we design our ARM-based embedded computers, they should have to be compromised between reliability and high performances. From reliability, all Moxa embedded computers are without hard disk inside, without rotating parts. They are fanless. They don't have a cooling rotating parts like in standard computers or laptops. They are robust and compact in size, and of course, they are intended to be used in industrial harsh environment. High MTBF values, mean time between failures, is the next property of our computers for which customers recognize Moxa as reliable hardware supplier. For Moxa, producing computers in extended temperature range from -40 up to +75 is a must, and we don't want to go into some models below this range. Low power consumption, as this small computer, is the next requirement that Moxa tries to satisfy. No matter if they are ARM-based embedded computing platform, which means very small and modest embedded computers, they should have to provide wide communication efficiency through the many different interfaces, beginning from serial, LAN, USBs, cellular, wireless, and so on. So all these computing platforms should have to be able to integrate many devices which are connected on computers to achieve protocol conversion, for example. They should have to have very short boot time, and they should have to be able to run embedded application. The first representative of our embedded computing product portfolio is UC-8100 series. UC-8100 series is in tri-level with PVC case. Here depicted the first representative of our embedded computer, UC-8131-LX. -LX means Linux operating system. About them we shall see in the latest part of this presentation, because all Moxa embedded computers are shipped with Moxa Industrial Linux, which we guarantee 10 years support and maintenance. The third digit in the name of the device, depicted here in a green color, actually presents the CPU clock. When you see the number 3, which means CPU is running on 300 MHz. Devices UC-8131 is equipped with one serial port, which depicts with red number 1 at the end, which means one serial port. It features also 2 Ethernet ports and 1 USB ports. But inside of the case is one mini PCI Express expansion slot for wireless or LTE module. The next representative of this computer is UC-8132, which is also based, you guess, on a 300 MHz processor with 2 Ethernet and 2 serial ports, which depicts the number 2 at the end of the name of the device. The next one is UC-8162LX, which is running on 600 MHz processor and has 2 serial ports, 1 USB and 2 Ethernet ports. And the most powerful from this ARM UC in tri-levels embedded computers is UC-8112LX, which is running on 1 GHz and has 2 serial ports, 2 Ethernet and USB ports. No matter about these computers, hardware is almost the same. It's running on Texas Instruments CPU, and inside is mini PCI Express slot to install Wi-Fi or LTE module according to your needs. You just need to connect it. Cables are already inserted, and just press the IPEX connectors on that inserted LTE module, attach antennas on the front, and you're ready to go. Be careful that Wi-Fi and LTE mini PCI Express module should have to be ordered separately. They are not constituted part of the shipment with the device. Moxa provides additional accessory package for these Wi-Fi and LTE modules. The next representative of UC-8100 series is UC-8100A, which comes with metal enclosure. Metal enclosure stands in the name of device ME. The first representative is UC-8112A, metal enclosure. T stands for extended temperature range, and LX for installed operating system, which is based on Debian 9 for ARM architecture. This computer comes without LTE module installed inside. But of course, you can open the case and insert the module inside, and you're ready to go. Cellular module using AT commands or Moxa cell management utility, or Wi-Fi module using Wi-Fi management utility. Moxa enables easy to run any of the LTE or Wi-Fi modules by customer side. The next representative is UC-8112A-ME-T-LX-EU or US or AP. When you see the end suffix in the name EU or US or AP, this means that this computer comes with already pre-installed cellular module in itself by Moxa. So module is already inserted inside. It is LTE category 4. And depending on different regions where this computer is going to be deployed, in Europe, United States, or Asia Pacific, it becomes the suffix EU, US, or AP. The other properties of this computer, which is very good and solid platform, are 2 Ethernet ports, 2 independent IP addresses, 2 independent MAC addresses, 2 serial ports. All serial ports are 3 in 1, which means RS-232, 422, or 485. 1 USB port, SD card for storage expansion, and the SIM card slots. Like mentioned, they are running on Debian 9 operating system with kernel 4.4. The curiosity of these computers is that actually they have very high MTBF. They can live like a humans, more than 70 years. You will see that in our last slide. The next representative is UC-8200 series product. UC-8200 series come in two different variants, UC-8210-T-LX-S, or it can be without S at the end, which means that it features TPM, Trusted Platform Management 2.0 model, which enables cybersecurity, encryption of the data. If you see the capital letter S at the end of the device, which means that the device comes already with pre-installed TPM module inside. If there is no capital letter S, then the device is without TPM. This computer is running on 1 GHz CPU and features 2 GB RAM memory and 8 GB eMMC. 8 GB eMMC is used to install operating system. Linux operating system, which is Debian 9, when installed on eMMC, has 6 GB free memory after installation on it, which means 2 GB are reserved for installations and the patches and the security installations on eMMC. Computer comes with extended temperature range between -40 up to +70 degrees Celsius, which you can see in the capital letter T in the name of the device. The device features also 4 digital inputs and 4 digital outputs, which means that you can wire I/O sensors without using external I/O devices, which can save the costs. It has one USB and one SD card as a storage expansion. The next representative is the same like UC-8210. We call it UC-8220 because it has already built-in category 4 cellular module, and it comes with dual-core CPU with 2 GB RAM and, of course, 8 GB eMMC. Different LTE modules which are deployed for different worlds depicted in the name of the device. If you see EU, Europe, US, United States, AP, Asia Pacific. In the capital letter S in the name of this device depicts the device coming with already installed Trusted Platform Management or cybersecurity features. Despite of this LTE module inside in UC-8200 series, there is additional slot for mini PCI Express Wi-Fi module. It is empty, and opening the case of this, you can insert Wi-Fi module into the device, and besides one LTE module, you can have LTE and Wi-Fi module in one device. Imagine an application where you can send the data from Wi-Fi network onto the LTE network. Of course, these computers is the same hardware like UC-8210, has digital inputs, outputs, and USB and SD card. The curiosity that installed operating system on Linux, Debian 9 on eMMC, like mentioned, customer can test his own Linux distribution, which he deployed for this ARM CPU architecture. And because the computer is able to boot from USB or from SD card externally, so he cannot, he mustn't, for example, touch our operating system installed on eMMC, but he can try his own operating system, how does it run, and test without touching the installed operating system. The next representative of our ARM product portfolio is Advanced Industrial Gateway, AIG-300 Series-AZU. This computer should have to be released at the end of this month. It is a similar hardware like the previous one you could see in UC-8200 series, and we call it Advanced IoT Gateway because it has already installed, we call it preloaded, Things Pro Edge and Azure IoT Edge software on it, purpose for connecting to Azure Cloud. Everything is installed by us. It enables seamless integration Azure IoT Edge, which makes using Azure Cloud very easy. The device AIG-300 series come with already predefined LTE category 4 for different bands, different regions where it will be used. For United States, depicted US bands are here. For European bands, supported are 1, 3, 5, 7, 8, and 20. And for Asia Pacific, they have different bands as well as for China. But in the case that customer doesn't need, Moxa gives possibility to order this computer without installed cellular module in it. Despite of this built-in already LTE, like mentioned, this hardware is similar like the previous UC-8200, which has built-in LTE module. If you open the case, you can insert additionally Wi-Fi module in itself. And this computer has very robust file system, which is in industrial grade. And this file system is based on redundancy. This file system can enable resume transmission in the case that connection was broken and enable redundant software that makes over-the-air upgrade mechanism even much better. Computers are enabled with secure boot, which prevents malicious software injection attacks, and installation of Things Pro proxy utility makes even device provisioning easier than ever before. We encourage you to try this incredible device. Difference in the hardware between AIG-301 and UC-8200 series are that this has more memory in itself, 16 GB eMMC, comparing UC-8200, who has 8, which enables more data to be stored, of course, and it comes with already pre-installed software from Moxa, Things Pro Edge with Azure IoT Edge. The next representative are our smallest embedded computer universal communicators, UC-2100 series. The first one is the cutest one and the smallest one. It can fit on a palm of each of us, UC-2101, which is running on Cortex A8 on 600 MHz CPU. It has 256 MB RAM memory and 8 GB eMMC, one Ethernet and one serial port, ideal, for example, to be serial to Ethernet converter programmed. The next one is UC-2100-LX, which means on 600 MHz. It has the same RAM memory and the same amount of eMMC where the operating system is installed, Linux. 2 Ethernet ports, and the curiosity, this computer doesn't have serial port on it. It has only 2 LAN ports, 2 independent MAC addresses, 1 LAN port on each side of this computer, creating him ideal as a protocol conversion from one protocol to another without serial ports. And look at the next device. The next device is UC-2104 Linux. The same hardware like the previous one, just instead of serial ports, it has on one side LAN port, on the other side are antennas, which means it features one mini PCI Express slot inside where you can insert LTE or Wi-Fi module, just attach antennas which are already predefined and connect antennas on the antenna connectors. Device is predefined to run on a cellular network, which means reverse polarity SMA connectors. But in the case that you're going to use Wi-Fi module inside, you insert Wi-Fi module, cables are the same, attach adapters to these cellular antenna connectors, adapters to Wi-Fi, connect Wi-Fi antennas, and you're ready to go. Very flexible solution, right? The next one is UC-2100-LX, which is running with 600 MHz. It has more RAM memory, double than the previous introduced computers, 8 GB eMMC, 2 Ethernet, and 2 serial ports. And if the memory is not enough, a customer would like to store more data, there is SD card as a storage expansion. UC-2111 has enhancement in UC-2112, which is running on 1 GHz CPU processor, is the same hardware like UC-2111 with 2 Ethernet ports. One is gigabit, the other is fast Ethernet, 2 serial ports, and 1 micro SD card. Requirements for extension of the temperature, bear in mind that Moxa design device with extended temperature range from -40 up to +75 degrees Celsius, which means the computer UC-2112-T-LX has installed operating system Debian on it and can run in industrial environment which requires high temperature ranges from -40 up to +75 degrees. The same hardware like UC-2112, just more enhanced through its carefully chosen component that can run under extended temperature range. These 3 computers are eligible to be DNV GL certified if necessary. We have already one customer from Netherlands who actually took our device and certified these computers according to his needs. Not to mention that the computers which are equipped with the serial ports here had already built-in termination and polarization register for serial lines. But look at the next slide. Moxa gives the possibility to visualize its embedded computers within its environment, within its visualized environment. We have our own software. Some of you maybe know it is MxView. Moxa View enables visualization and management, remote management of Moxa devices, switches, wireless, gateways, I/O devices. But now we have the possibility to integrate our embedded computers into our MxView software, thanks to SNMP protocol version 1, version 2C, and version 3, and LLDP. It is easily integrated into the existing network and enables visualization of our embedded computers in such environment. Besides of this visualization, customer can easily upgrade operating system remotely or make resources, reviewing the resources of the CPU, memory, or disk usage of embedded computers with just one mouse click. Whoever uses Linux platform on the shell, he knows how it is a little bit difficult and what commands you need to issue, and they are not so in human readable format, presented to be easily understood how much is occupation of the CPU or memory or disk usage. But on one mouse click in MxView of this UC-2100 series, customer can get overview of all the features with very simple way. Moxa will continually integrate all other embedded computers till the end of the year in this visualization software. You don't need to buy anything else. You just need to install the latest firmware and install MxView, which is free for 20 nodes of usage. Our next representative of embedded computing product portfolio is UC-2100-W series, which comes in the two versions, UC-2114 and UC-2116. Now, what is the difference between UC-2100 that I showed you before and these computers? This computer has already integrated LTE module in itself. Actually, cellular module is here designed for category M1 or narrowband IoT. These computers are narrowband IoT gateways, ideal for application usage where the computers don't need to consume too much cellular traffic to save the bandwidth if there is no too much data to be sent. Besides of these features of UC-2114 and 2116, the main difference between these two platforms is that UC-2116-T-LX has built-in GPS module, which enables him to be used in some vehicles, tracking the GPS location of embedded computer, of course, the vehicle where it is moving. And this GPS is implemented on a separate chipset, a part of cellular module. Why? Because according to our R&D, sometimes GPS signals can interfere with cellular signals, giving imprecise position. We all faced on our mobile phones, smartphones, that we are using such issues sometimes. But Moxa discovered this and decided to design GPS on a separate chip, a part of this cellular module. The next representative is of Moxa ARM-based embedded computers are UC-8100 series in the latest version 3 hardware. We call it all-in-one because it has everything you might need, an LTE and Wi-Fi module built in these computers. The first representative is UC-3101-T. You will recognize that it is already for extended temperature range, -EU, US, or AU, depending of which region this computer is intended to be used, Europe, United States, or maybe Asia Pacific, Australia region, and LX. It comes only with LTE module built in inside, 2 GB Ethernet ports, dual SIM slots, 1 USB and 1 serial. UC-3111 embedded computer has integrated an LTE and Wi-Fi module on from Moxa. Those modules which are integrated enables him great for applications, and cellular module is already certified by Moxa. It is provided proven running as well. 2 gigabit Ethernet ports enables 2 independent MAC addresses, 2 independent networks to be designed and connected. Imagine the application for wire to LAN or to cellular, or LAN to cellular, or LAN to Wi-Fi, unlimited applications. And the strongest representative of this UC-3121-T-EU-US AU or LX is presented also with integrated LTE and Wi-Fi module, but the curiosity that it has also 2 CAN bus ports, which makes him ideal to be used in automotive industry. UC-8100 series version 3 supports also cybersecurity, on which Moxa relies a lot in the last years. TPM 2.0. It comes with Bluetooth 4.2 with Bluetooth Low Energy. Moxa takes care to implement such features which can save customer money, like, for example, MX Power Management. MX Power Management enables the computer to come into sleeping mode, which consumes very low energy. In this mode, computer consumes only 50 milliwatts. It's almost nothing. Imagine the application where you can build this MX Power Management tool in your Linux script, and you can wake computer every 10 minutes to send some data and come into the sleep mode again. If he does 6 times per day with a couple of seconds, the computer will not consume more than 70 or 80 milliwatts. It's nothing. And of course, to easily manage with LTE and Wi-Fi modules, Moxa enabled its own utility MX-module-control. The next representative of our ARM-based embedded computers, IoT gateways, is UC-5100 series. They are not only purposed as IoT gateways, but they can be used in factory automation due to its large number of serial ports. The first representative is UC-5101-T-LX. The next one is UC-5102, which has enablement for Wi-Fi or LTE module. The third one is UC-5111-T-LX. And the last one is UC-5112-EU-US-LX. What are the differences between modules? They all run almost the same hardware. They have 2 gigabit Ethernet ports, 1 USB, SD card slot for storage expansion, but it will be also able to boot customer operating system from this card, and 4 serial port realized through the RJ45. The computers which are equipped with Wi-Fi and LTE modules supports also dual SIM socket, and UC-5111 and 5112 has 2 CAN bus ports which supports both standards, CAN 2.0A and 2.0B, which made them ideal to use maybe in automotive industry, despite of factory that it can be used in factory automation and as IoT gateways. Please bear in mind that these Wi-Fi and LTE modules in 5102 and 5112 can be ordered and purchased separately from Moxa, or customer can install them on their own. Moxa UC-8540 series product portfolio is designed for railway application according to standard EN 50155. They are certified, these computers, with QMA antenna type connectors. There are 3 different versions: UC-8540LX, UC-8540 with extended temperature range, and UC-8540-T-CT-LX. Like it states in the name of this device, capital letter T extended temperature range from -40 up to +70, like mentioned, and CT stands for conformal coating, which is sometimes very demanded in railway, especially if the environment should have to be humid. All the PCB inside is sprinkled with a lac inside, which sealed all the electronic components on it and prevents humidity to damage the electronics. Moxa delivers also this type of embedded computers. But it has dual SIM slots for cellular and Wi-Fi. In the case that it is not enough, you see how Moxa is very friendly company to develop even more robust solution through the UC-8580 series product portfolio. It comes in the 2 versions, UC-8580-LX or UC-8580-Q-LX, which means with the standard SMA connectors or with QMA connectors. But inside of these computers, like you remember in the previous 8540, you have only one SIM slot. But here you have possibility 4 mini PCI Express slots. 3 of them are reserved for LTE modules and 1 for Wi-Fi. Imagine the application where trains with installed this embedded computer in itself should communicate amongst themselves if they are on the same track to avoid train collision. They can communicate themselves based on this and send the data in OCC center and can be remotely managed. These computers, besides of this fantastic feature, is that they are designed for railway applications and a lot of mini PCI Express slots inside. Also have 2 M12 gigabit Ethernet ports, 1 mini SATA slot inside for installation or expansion of the for the data storage, 1 USB Type A, 3 digital inputs and digital output with 3 kilowatts optical isolation, making ideal to install and to wire additional I/O sensors, which are presented in the train and can save the saving cost because you don't need external I/O devices. Customer can choose this device as SMA or QMA type of connectors. The next representative of Moxa's ARM-based embedded computers are UC-8410A. UC-8410A come in the 2 versions with installed wireless module inside or no wireless module inside. That depicts the name of the device. When you see NW, which means no wireless module inside. UC-8410 is proposed with 1 gigahertz dual core CPU, which is running on 1 gigabyte DDR3 memory, and it features very high density of serial ports, RJ45 realized. All serial ports, 8 of them, are RS-232, 422, or 485 software selectable. 3 dependent LAN networks are presented, 3 independent IP addresses. USB hosts for data expansion, storage expansion, or for booting external operating system. And like all Moxa embedded computers, they are coming with a fanless design because we have special cooling mechanism that cool the CPU through the heating pipes and retrieving them into outer space. If that is not enough serial ports, Moxa provides DA-662A series. DA-662A series comes with 8 or 16 serial ports, and we have 3 different versions to present them. Like mentioned at the beginning of this presentation, this embedded computing platform has Moxa CPU in itself, Moxa macro CPU in 500 MHz. And in the case that customer needs extended temperature range, he should have to choose DA-662A with 8 or 16 ports with capital letter T, which means extended temperature from -40 up to +75, -LX, installed Linux operating system on it. In the case that customer needs redundancy in the power, he's not sure, his power is not stable, we are providing device with dual power input wide range from 100 up to 240 volts AC with isolation. And when you see the capital letter I in the name of this device, it means that serial ports are optically isolated. In this case, DA-662A-8-I-LX has 8 RS-232, 422, 485 serial ports, which are optically isolated and has in all of them serial ports is built in pull up, down, and termination resistor, which can save the costs for buying external resistors and wire them in such maybe narrow space where this device can be installed on it. The features of this computer that it comes also with LCM display on the front with the 4 buttons. The device can be very easily configured, so you don't need to log in into the console. You can do it from the buttons from the front side. IP address, subnet mask, and similar things like gateways, you can define it on your own. Like mentioned, they are all ready to run Linux embedded operating system platform. And now, a couple of words about Moxa Industrial Linux. Why? What is Moxa Industrial Linux, and why long-term support of Linux operating system? Well, Moxa embedded computers platforms are used in industrial environments that have to take more than 10 years. Actually, these computers, when installed, they should have to be able to run without any problems, without reinstallation of the operating system. They don't want to be forced to upgrade application software because of operating system end of life or breaking changes with major new releases. And not to mention about the security patches and bug fixes the customer doesn't want to install. So the Linux community provides long-term support LTS releases, which are based also in Moxa Debian distribution that we are deploying on our ARM architecture. By maintenance of these LTS long-term support Linux kernels, it is in a question of civil infrastructure platform. CIP is actually a collaboration platform maintained by Linux Foundation, and it supports key Linux projects. Actually, it uses upstream patch strategy, reduces the speed, which is not so demanded in an industrial environment, but more reliability, and increases compatibility and smooth patching. Through these concepts of CIP and long-term support, actually the Linux kernel and can be turned into the superior long-term support, which you are going to see in the next slide. So Moxa Industrial Linux is actually based on civil infrastructure platform, providing superior long-term support of the kernels. All packages are able to be updated no matter Linux kernel or Moxa device driver by providing 3 years of full support and 7 years of maintenance support. This is in a version 1, which run in 2021, and Moxa will create Moxa Industrial Linux version for each of major Debian release, which means version 1.0 long-term support, version 3.0 long-term support, or 5.0 long-term support, which will be based on Linux Debian 9, 11, 13, and the versions in between, which all upgrades of the kernel and the patches and the security patches Moxa is able to provide within 10 years of support. So how many SLST versions are realistic to support concurrently? Approximately every 4 years, we are able to expand it and to support such long-term support operating system to the MIL standard of Moxa. And I would like now to explain you why customers choose the Moxa embedded computers. Based on slides which you have seen, we provide Moxa Industrial Linux of 10 years support with its maintenance, 5 years on hardware support. Our computers are very well known that can run for many years. It has very high MTBF. It can live like a human for more than 70 years. The best satisfaction of the customer is low RMA rate, which means the customer doesn't return us devices to be repaired, which is in this case of ARM architecture, less than 1%. All Moxa embedded computers are designed to run from -40 up to +85 degrees Celsius, and designed with different certification in mind where the computer should have to be used in. It provides Wi-Fi and LTE redundancy and provides crash-free robust file system that will not become device brick in the case of upgrade of the operating system crashed. Moxa added values are also the software for cloud connectivity, things through gateway and edge, and integration with input-output external devices through the MxIO library. And our recommendations is actually more than 45 models with different combination of CPU, memory, storage, IO interfaces, and we are sure that some of these models can find a place in your application as well. Thank you.
Thank you, Igor. I particularly liked when you said the cute UC-2100. I totally agree. I'm not sure if everybody understands the cuteness of that box, but we're working on that. Very good.
Cute and powerful. Thank you.
Okay. So the last section is about how to use the products again with Moxa IoT partners. If you look at the gateways, and we just have looked at the gateways, in itself, they don't solve any customer problem, really. It's just the computer. So what we try to do is for the sensor to cloud applications to make it easy, fast, and scalable as well for our customers. And we can't do that ourselves alone. And therefore, we're working with a number of different partners, sensor partners at the bottom, if you like. So we work on Ethernet-based protocols. We work on serial-based protocols, analog I/O, digital I/O, USB connections. And we've started to work on Bluetooth Low Energy and LoRa, in particular with our partner Digital Nordics from Sweden. And then we have the data. That alone is already not so easy, but really typically the software side gets more complicated. Once you do have the raw data, what do you do with it? And we've got a number of software partners that we're working with. The first use case that we looked at the beginning was with Robotron, actually a German system integrator and software and machine learning expert. And then you have to send the data to the cloud. In the past, it would have been the SCADA system. Nowadays, it's all kinds of systems, typically on the cloud, but not necessarily on the cloud. And then there are additional partners for device management and remote access that we're working with. Today, I want to give you the example of 3 partners that we're working with, TeamViewer, Crosser, and Keepler, to give you an idea how grand things are possible if you do work together with partners. So let's have a look at TeamViewer first. Most of you will know TeamViewer as the remote desktop application company that they are, but for a number of years, they've started to invest heavily and make strong acquisitions in the area of IoT and augmented reality. So let's have a look at the TeamViewer IoT architecture. Here you can see a PC with TeamViewer installed. The new thing here with IoT is the TeamViewer IoT agent on the gateway, and then you can remotely access the device from wherever. You can collect the data, you can remote terminal into the unit, you can have a remote screen. Together with our Things Pro software, for instance, it has a web GUI, local web GUI, that you can suddenly use remotely as well with the TeamViewer application. And you can do some local processing, sending data to the cloud, both for device management and for the data path. But you can also just use it for a device management solution and then send the data maybe somewhere completely different. One of the really nice and interesting new applications that they can support with that model is also augmented reality. So smart glasses in industrial environments in particular. You may wonder, what has that to do with IoT? Well, smart glasses display data in your glass. And here you can see there's actually a whole video that explains why that's a good application and why that saves a lot of time and increases the quality of what they do. The data displayed here is the master data about the piece of equipment that they're handling, or they give instructions and so on. In many cases, this data is basically IIoT data. And that's the connection here, and that's what the platform that I will not even try to explain actually supports, and that's really an exciting area. A very different focus has Crosser. So Crosser is a Swedish company that makes software to allow to control the software on the gateway, also in the cloud, but here let's focus on the gateway. So you can have the physical connection as before, then you have that real-time engine running on the gateway with flows and connected modules. You can connect lots of things, not just what you can see here. And the good thing is you can design and control and monitor and update it all from your cloud-based console. For those of you who know Node-RED, it looks a bit like Node-RED, so it's low-code, visual, really easy and fast to deploy. And to update, and you can do that for one gateway, or you can do that for 10,000 gateways at the same time. So it's really highly scalable. And Göran, the CTO of Crosser, just did his weekly webinar about the most common edge analytics use cases 2020 2 weeks ago. So check their website for that webinar. The recording is there. And he explains in detail how the Crosser platform can support all these use cases. The last partner I want to show is yet again, with a totally different focus. It's Keepler. They have a lot of experience with big data analytics, machine learning, artificial intelligence in the cloud and also at the edge. So to give you an example of what they can do, here's an example with the Moxa MC-1200. We're going to hear more from Igor next time about the x86 product line. So it's a fairly strong edge computer already, DIN rail mountable, and it can take the video feeds, and then you can, here's the imagination that workers on an oil rig, for instance, need to wear helmets. Actually, Keepler has programmed a helmet detection application for big construction sites already. So they have video surveillance. They check if the workers actually are wearing a helmet in those areas where that's a requirement, and if not, they can react in a certain way, either informing those workers or the managers. And here also, if you're in an oil rig and you fall off and the video stream has that recorded and you program the device for it, then you can detect those accidents as well. A much more, and this is local computer vision. So the machine learning runs on the edge computer. The last thing I want to show you now is a really big data project. Customer Cepsa, oil company from Spain. Again, more details are on the Keepler website. Is using a huge data lake now, so lots of data from all over that process automation of that plant, and that's what Keepler helped them build, the data lake, and then the analytics to optimize the process. So less waste, less cycle time, and so on. That is, process automation is a really good area to do that. And with the right IoT data and other data and the data lake and the analytics, there's a lot of efficiency that can be gained. Right, that's the end of the story. We wanted to give you a bit of an overview of what applications, what hardware products we have. Next time, we're going to do a bit more demo. And then also talk about the right-hand side of our computing portfolio for IoT and edge computing, namely the x86 products. Over to Simon and Jean-Frederic.
Thanks, Simon. Thanks, Igor. I think a very good overview and some interesting stories. We do have a couple of questions quickly, so interesting ones. So do we have an example of an old project, maybe from, let's say, 5-10 years ago, that people would call IIoT today, but the name didn't exist back then?
Igor, do you want to take it, or should I?
Maybe you can answer it. Maybe on it.
Don't bother.
Okay, we did, I think, possibly one of the most, in terms of units sold, one of the biggest project we've done is probably 10 years old, with a cute UC-2100, where a system integrator used it as an SNMP connector. SNMP adapter is what they called it. So they had a management system. They wanted to control certain industrial assets that were not accessible. So they used the 2101 and were able to get the data from that industrial piece of equipment. And in the power space, it was over serial. And they wrote a little program to get data from the device and also make simple ways to control it via SNMP and a fairly traditional network management system. So very simple use case, but very effective, and to some extent, it almost crossed the border to the IT system, I would say. So you could, I guess, call that IoT, I would say. But actually, there's lots of them. So, but I don't think we have so much time.
Maybe we can touch on that afterwards. So
yeah, next time.
The second question, sort of along a similar vein, I guess. So what does Moxa do differently for IoT projects now compared to 5 years ago, and why?
Okay, I guess it was touched on in the past, and Igor, feel free to add to it, but maybe I can take the first answer. I think we've focused on the product a lot in the past. Nowadays, we try to work with partners more to address projects and have a more solid end-to-end solution for our customers. And I would say that the biggest value in there is the speed. Because if you start with or if the customer asks us, can you help with your gateways in a certain environment, and then we start designing the solution, then it's already too late. So if we work with partners, pre-integrate the components, do a proof of concept together or demo in the beginning, and maybe in the best case have some reference cases already, then you are in a totally different position to answer customer requests. And building that ecosystem around our partners and with our customers, I think that's a big change. And it's not just Moxa who does it, but it's also Moxa who does it. And I think that's looking quite promising, I would say, in terms of speeding up projects and also working with partners that really focus on it. It makes it scale a lot better.
Okay,
and
so
faster.
I know we're just over time, but we do have one final question, I think more for Igor. So Igor, which series is capable of running the Azure IoT runtime engine except for the preloaded model? So I'm presuming where you were talking about the AIG, but
AIG-301 and UC-8200 series, then UC-8100 series, 8112A that I presented. So you can install the things for Edge, but in the latest part of this year, Moxa will give ability things for Edge software to be installed. Currently, for things for gateway software that enables communication to the cloud, like Amazon, like Azure, and so on, can be installed on any of these UC embedded computer series, UC-2100 series, 3100, 5100, 8100, 8100A, 8200, all of them. But things for Edge is able to run with Azure IoT Edge on AIG-301 and UC-8200 series because of memory constraints, and UC-8112A.
okay, perfect.
We'll talk about the x86 product line next time, right?
Yeah.
Next time we shall give
it does run too.
yes.
We'll confirm the answer back to the customer that asked. So I'll get John Frederick to do that. Okay, thank you. Anything from your side, John Frederick? You're talking to mute.
Not really from my side, except so I think that we are kind of done. Please keep in mind that we have a second part that is written there on the 7th of April, just after Easter, and Moxa will show real-time demo, and so join, register, and it's going to be also a great webinar. So thank you, Simon, Herman, and Igor for a great presentation.
Thank you.
Thanks a lot.
Thank you.
Thanks to everybody for attending.
Have a good rest of the day. Bye-bye.
Bye-bye.
Greetings to attendees. Bye-bye.